All right, so we are looking at section 3-2, part 2 today. And basically the goal of today's section is to learn how to solve a system using a new method. So yesterday, our method for solving systems was substitution. So we had x equals 4 in this case, and we have 2x minus 3y equals negative 19. So you would take the x equals 4 and you would place it in where you had x in the second equation. So you had 2 times 4 minus 3y equals negative 19. 2 times 4 is 8 minus 3y equals negative 19. Subtract 8 from both sides. And you get negative 27, divide by negative 3, and we get y equals 9. In number 2, what you need to do is you need to move over the 3x so we can solve the top one for y. So you have y equals 7 minus 3x. So we're going to replace y with 7 minus 3x. And then you have 4x plus 14 minus 6x equals 16. And then you have negative 2x plus 14 equals 16. Negative 2x equals 2. Divide by negative 2. And x equals negative 1. But again, having simply x isn't enough. You need to take that negative 1 and plug it back in. So you get y equals 7 minus 3 times negative 1. A negative times a negative is a positive, so 7 plus 3 is 10. And then we're going to look at the bottom two equations. And we're going to once again solve for the variable that has a coefficient of 1. So in number 3, the y has a coefficient of 1. So we're going to solve for y. Substitute it in. Combine like terms. Divide by 9. Okay. And then we're going to look at number 4. All right, so back to this. Let's go with number 4. We have x equals 2y. Then we have 2 times 2y plus 2y equals 4. So then you have 4y plus 2y equals 4. So 6y equals 4. And then you get y equals 4, 6. or 2/3. So that is yesterday's technique, which is known as substitution. So what we're going to do today is look at a new technique called elimination. So elimination is a technique in which we eliminate a variable. So what that means is we're not going to alter the equations. We're simply going to add or subtract them together. So in this first equation, 3x and negative 3x are what we call additive inverses. So if I add these two equations together, then what happens is we have the ability to eliminate the x's because they're additive inverses. So 3 and negative 3 give us 0. 1y and negative 2y gives negative y, negative 9 and 12 gives 3. So we get y equals negative 3. Then what you have to do is take that y equals negative 3 and plug it into the top or the bottom equation to solve for x. I always try to pick the equation that the y value is the simplest. So in the top one, it doesn't multiply by anything. So I'm going to replace y with negative 3 and solve for x. Now again, it doesn't matter which one I would have plugged it into. Both equations should give me x equals negative 2. And if they both did not, then I've done something wrong. Okay, number 7, add those two together. 5x equals 20. Divide by 5, x equals 4. And then you take x equals 4 and you plug it in. So let's plug it into the second one this time. And you get x equals negative 1. In number 8, I don't have any additive inverses. However, I have two terms that have the same number. So instead of adding the equations, if I subtract the equations, 4x minus 4x zeroes out. 9 minus 6 becomes 3y. 1 minus a minus 2 becomes a positive, so you get 1 plus 2, which is 3, and we get y equals 1. And then we're going to take that 1 and we're going to plug it in. So we have 4x plus 9 equals 1. Add a negative 9 to the other side. You get 4x equals negative 8. And x equals negative 2, because negative 8 divided by 4 is negative 2. Okay? Okay. Number 9, we are going to look at these and say, oh no, elimination doesn't work because I have a 2 and a 3, a 4 and a 5. So what we have to do in number 9 is actually alter one equation to eliminate from the other. And sometimes it's not even just one equation that's going to work. Sometimes it takes altering both. So let's say we want to eliminate the m's. We're going to maybe get them to the number 6. So what we're going to do is multiply the top equation by 3 So 2 times 3 is 6m. 3 times 4 is 12n. And negative 4 times 3 is negative 12. And they're going to multiply the bottom equation by negative 2. So you get negative 6m, negative 10n, and a positive 6. So now the m's are additive inverses, so we can add them together. And we get 0 plus 2n equals negative 6. So n is negative 3. And then we're going to take that n and plug it back in. And I always like to plug back into the originals because the numbers are smaller. So you get 2m plus 4 times negative 3 equals negative 4. And then you get 2m minus 12. And then you're going to add 12. So you get 8. Divide by 2. Let's try eliminating x just for the heck of it. So multiply by 5. 5 times 3 is 15x. 5 times 7 is 35y. And 5 times 15 is 75. That's where I goofed up. I swear I did not have a 30. Okay, and then times negative 3. So you get negative 29y equals 75 plus 12, which is 87, and 29 goes into 87 nicely 3 times. So you get y equals negative 3. That sounds more like what I was hoping for. And then in number 10, part 2, you're going to take that 3 and plug it back in. So 15 minus 21 is negative 6, divided by 2 is negative 2. Number 11, this one's set up that you only have to multiply your top to get to elimination. So you get negative 6x, positive 10y, positive 12. A negative and a positive 6x is 0. A negative and a positive 10 is 0. And a 12 and a 0 is 12. Does 0 equal 12? No, it does not. So since 0 does not equal 12, this is a case of no solution. And if you have a case of no solution, then what's really occurring is that these are parallel lines. And that should make sense because if you compare the slopes, the slope here is negative a divides b, so it'd be 3/5, And over here, it would be negative 6 over negative 10, which would reduce to 3/5. Number 12, same idea, we're going to multiply by 2. But this time we get 6x and negative 6x is 0, negative 10 and positive 10 is 0, and negative 12 and positive 12 is 0. So 0 does in fact equal 0, and when you get 0 equals 0, what that means is that these are the exact same line, which means they are coinciding, which means there is not 1, there is not 2, there is infinitely many solutions. Okay, number 13, let's multiply by 2. And we can see that it happens again. So anytime you get 0 equals 0, all of that is true. And last but not least, we got to go back to eliminating both multiplying top and bottom. So let's multiply the top by 3. Let's multiply the bottom by negative 2, so I can get a positive 6x. And we get negative and positive, so they cancel. Negative and positive, so they cancel. Equals 2. And again, we know 0 does not equal 2. So that means no solution because they are parallel lines. Okay, your homework is in the textbook. It is in the textbook. Well, it is, but it's in your packets as a page that I made for you. It is 3-2 solving day 2. So again, yesterday your homework was the 3-2 solving day 1. So both of those handouts are due tomorrow morning by 7:30 a.m. Have a great day.